All right, so anyone else a little freaked out by just how much stuff is falling out of the sky these days?
Falling out of the sky,
Yeah, like, all that space junk we've been sending up for decades.
right?
It's well, it's coming back down.
It is coming back down,
Yep.
and it seems like more so than ever.
Yeah, it's kind of wild. I mean, over 1,200 objects crashed back to Earth last year.
1,200 that we know
Yeah.
of. Yeah, and that's not even counting all the tiny little bits and pieces.
Oh yeah, right. The stuff that burns up on reentry.
Exactly.
Mm.
But even just those larger pieces paint a pretty concerning picture.
It's like a constant rain of space debris.
A rain of space debris, yeah. It's not exactly the kind of weather forecast we want to be hearing.
No, not at all. And I think that's why I wanted to dig into this today because, it's not just about some abstract risk. It's about stuff that directly affects all of us right here on Earth.
Absolutely, and that's what this recent report from the European Space Agency, the ESA, really highlights.
Right. The ESA report, it's pretty eye-opening stuff. I mean, they go into a lot of detail about the growing problem of space debris.
They do, and what's particularly striking is how much of this debris is concentrated in low Earth orbit, or LEO.
LEO, right? So for folks who aren't familiar with that term,
LEO is essentially the region of space from a few hundred to a couple thousand kilometers above Earth's surface.
okay, so relatively close.
Yeah, relatively close, and crucially, it's where a huge amount of our most important satellites operate.
Like what kind of satellites are we talking about here?
Everything from imaging satellites that help us monitor weather patterns and climate change to the International Space Station to, the vast majority of those communication and internet constellations that we all rely on.
So basically the backbone of modern technology is up there in LEO.
Yeah, it's a pretty critical zone, and as the ESA report points out, it's getting increasingly crowded and increasingly dangerous.
And I think that's where that number we started with 1,200 objects crashing back to Earth in a single year that really starts to hit home, right?
It does, because it tells us that on average, more than 3 large objects were re-entering the atmosphere every single day.
Every single day. Wow, that's a lot of stuff falling from the sky.
Yeah, and it gives us a sense of just how much is still up there just waiting to come down.
Which is a lot, according to the report, right? Something like 1.2 million objects larger than just 1 centimeter.
1.2 million, that's the current estimate. And even those tiny pieces can cause serious damage.
Yeah, I mean, I remember reading that even something the size of a marble,
Yeah, even something that small traveling at orbital speed,
which are incredibly fast.
thousands of kilometers per hour, can have the impact of a grenade hitting a satellite.
A grenade.
It's not a pretty picture, and that's why this whole issue of space debris is so concerning.
So we've got all this stuff up there zipping around at crazy speeds, and the risk of collisions is only increasing as more and more objects are launched into space.
Exactly, and here's the kicker. Even if we stopped launching things today, the problem wouldn't go away.
It wouldn't.
No, the ESA report makes it clear that the existing debris field has its own sort of self-sustaining dynamic.
What do you mean by that?
Well, collisions between pieces of debris create even more fragments, and those new, smaller pieces then increase the probability of further collisions. It's a bit of a runaway chain reaction.
Oh, I see. So it's not just about preventing future debris from being created. It's about dealing with the debris that's already up there.
Absolutely. And that's where this concept of the Kessler Syndrome comes in.
The Kessler Syndrome, that's kind of a scary term.
Yeah, it's not exactly a cheerful topic, but it's important to understand what it means.
So what is it exactly?
Well, the Kessler Syndrome, named after NASA scientist Donald J. Kessler, who first proposed the idea back in 1978.
Back in 78. So this isn't a new idea.
No, not at all. It's been a concern in the space community for a long time, but it's becoming increasingly relevant as the amount of debris in orbit continues to grow.
So what did Kessler propose?
Essentially, he described a tipping point where the density of objects in LEO reaches a critical level.
A critical.
And at that point, collisions become so frequent that they trigger a cascading effect. Each impact generates more debris, leading to even more impacts, and it just keeps escalating.
So it's like a chain reaction, but on a cosmic scale.
Yeah, and the potential consequences are pretty dire. The worst case scenario is that large swaths of LEO could become completely unusable for decades, even centuries.
Unusable, what do you mean?
Imagine an environment so saturated with debris that it's simply too dangerous to risk operating satellites there.
That would be devastating, right? I mean, we rely on those satellites for so much.
Yeah, it would cripple everything from global communications and navigation to weather forecasting and climate monitoring. It would essentially slam the brakes on the space age.
And it would be our own doing.
It would, and that's the really sobering part of this whole issue.
But is that a certainty or is it more of a worst case scenario? What are the chances of actually reaching that tipping point?
Well, that's the multi-billion-dollar question, isn't it? It's not a guaranteed outcome, but the ESA report suggests that the risk is definitely increasing as the density of debris and the number of launches, particularly these large satellite constellations, continue to rise.
So what can we do about it? I mean, is it too late to turn things around?
Well, the ESA report emphasizes that simply preventing future debris isn't enough at this point.
It's not.
No, we need to start actively removing some of the larger, more dangerous pieces of existing debris from orbit.
Active debris removal, that sounds pretty high tech.
It is. It involves developing technologies and missions specifically designed to go up there and capture debris and then either deorbit it so it burns up in the atmosphere or move it to a less congested orbit.
So it's like a cosmic cleanup crew.
Yeah, something like that. And it's not going to be easy or cheap. But the report argues that it's becoming increasingly essential to prevent this situation from spiraling out of control.
So it's kind of like we've created this mess and now we have to clean it up.
That's a pretty accurate analogy. And the longer we delay, the more difficult and expensive the cleanup is going to be.
Yeah, I get it. And it's not just some abstract problem either, right? I mean, the report mentions a couple of pretty scary incidents from last year.
Oh, yeah. There were a couple of high-profile cases where debris actually hit the ground.
Like what?
Well, in December of 2024, the Kenya Space Agency reported that large metal fragments from a nearly 500-kilogram rocket stage crashed into a village in Makueni County, Kenya.
500 kilograms, that's huge. Imagine that falling out of the sky near your house.
Yeah, it's a pretty sobering thought. And then in February this year, just a couple of months ago, a large piece of a SpaceX Falcon 9 rocket landed on someone's property in Poland.
In Poland, wow. And that was from a recent launch, right?
It had been launched from California with a batch of Starlink satellites.
So even with all of our tracking capabilities and supposed safety protocols, this stuff is still happening.
It is, and it highlights the fact that these uncontrolled reentries can happen anywhere.
So, okay, let's just recap what we've learned so far. We've got a significant and growing problem of space debris, particularly in low Earth orbit.
Yes.
This debris poses a very real threat to operational satellites, including the International Space Station.
Right.
And the Kessler Syndrome, this idea of a runaway cascade of collisions, presents a pretty terrifying scenario for the future of space exploration and for our reliance on space-based technologies here on Earth.
Exactly.
And we've seen tangible evidence that this debris can and does come crashing back to Earth, sometimes with traumatic consequences.
And all of this points to the key takeaway from the ESA report.
What's that?
The situation is becoming increasingly urgent. We can't afford to keep kicking this can down the road.
We need to act now.
We do. We need to invest in active debris removal technologies, and we need to adopt more responsible spaceflight practices to prevent the creation of new debris.
If we don't, the consequences could be catastrophic.
Catastrophic not just for the future of space exploration, but for our modern way of life here on Earth.
So here's a final thought for all of you listening, given how much we rely on space-based technologies for everything from communication and navigation to banking and transportation and even things like weather forecasting and disaster response. What would happen if access to low Earth orbit were suddenly compromised or even denied because of this escalating problem of space debris?
It's a question worth pondering.
It is, because it's not just a problem for scientists and engineers. It's a problem that has the potential to affect every single one of us.
It's a global problem that demands a global solution, and the time to act is now.
Well said. Thanks for joining me for this slightly terrifying but definitely important deep dive into the world of space debris.
Anytime it's a conversation we need to be having.
Absolutely. All right, folks, that's it for this episode. Until next time, stay curious and maybe keep an eye on the sky.
And maybe invest in a good hard hat.
Yeah, maybe a good hard hat wouldn't be a bad idea.
Just in case.
Just in case. All right, we'll see you next time.
See you then.